Alright, hello everybody. I'm going to go through the exercises that we did in class in TD last week. Just because I had some questions about them, and also because it's easy enough to make these videos. I really like the Khan Academy stuff, so maybe this can help you as well. So let's do it. This is exercise 1 from the slides. I recommend, if you struggled at all in class, to go through it. If you didn't struggle at all, don't watch this video. So let's begin with question 1. It wants us to compute the tax multiplier given an increase. So let's start with a general what happens if taxes change at all, which we'll get by getting the derivative of the equilibrium state of the system. So the key thing to remember is that in equilibrium we have that dd equals y. So let's make that substitution so that you get y is 5,000 plus 3/4 y minus t plus g bar minus 100i. We're going to just gather all the y terms and solve for y. So just algebra, we'll have y minus 3/4 y, and that came from this one here. That came from right here. I just took it over. And then there's no way I'm getting the same color back, which is a shame. That will equal, I didn't do too bad. 5,000 minus 3/4 t, which comes from this factoring, plus g bar minus 100i. Then we'll factor out a y, so we get 1 minus 3/4 y is equal to 5,000 minus 3/4 t plus g bar minus 100i. And then 1 minus 3/4 is 1/4. So we'll have 1/4 y equals ... and we're going to take that over. So we'll multiply everything by 4. So we'll get y equals 20,000 minus the 1/4 and the 4 and the 1/4 cancel. So we get 3t plus 4g bar minus 400i. And I will draw a box around it, even though it is not the answer to the question. So the answer to the question is, what happens when the value of t changes? So let's begin the actual answers. So number 1, we want to know what happens when t changes. When you want to know about a change, you take a derivative. So we want to know the derivative of y with respect to t. And since this is a linear equation, it's very easy. We just look at the coefficient right here, minus 3. So we're done. We're not done. This is the change given a 1 unit change in t. So if t changed by 1, then it changes by minus 3. We want to know what is 3,000 to 3,500. So it's going to be a delta of 5,000. So we just do minus 500, excuse me. Minus 3 times 500, which would be minus 1,500. And now we are done. For number 2, it's asking us the same question with respect to g. Yes, with respect to g. So dy dg bar. And again, we just read off the coefficient, and that will be plus 4. And then that's a 1 unit change. We want to know a 500 unit change, so that will be 4 times 500, and that will equal 2,000. And we're done. Now it wants to know the net effect on GDP of both changes. So we want to know the total effect of a change in y with respect to a change in g bar plus a change in y with respect to a change in t. And we know that already. That's going to be minus 3 plus 4, which equals 1, times 500 equals 500. And there you go. So I guess the only thing to note here, this is all very simple math-wise. You just have to remember, number 1, this point about setting equilibrium. And then having in mind the notion of change equals derivative. And we're taking these derivatives because we want to understand how our model reacts to changes in the conditions of the economy. In principle, these could be more complicated. I mean, here, I guess you don't really need to take a derivative You just read it because it's linear, but you can imagine that it's nonlinear, it's more complicated. So having this procedure in mind is quite nice. So that's it for this video. I will make another one where we will do exercise 2. So I will see you there.